Hello friends, I welcome you in lecture number 3 on eigenvalues and eigenvectors. In this lecture we will discuss triangular matrices and we will see how to find out eigenvalues of triangular matrices without using definition of the eigenvalues. So triangular matrix, there are two types of triangular matrix, lower triangular and upper triangular. So triangular matrix is a square matrix. We can define triangular matrix for square matrix only. So a square matrix in which all the entries above the main diagonal are 0 is called lower triangular matrix, and a square matrix in which all the entries below the main diagonal are 0 is called upper triangular. And a matrix that is either upper triangular or lower triangular is called triangular matrix. We can understand with the help of example. Here we are given this square matrix and we can see, if we consider this main diagonal which is containing these entries 1, 2, 5, then all the entries below this main diagonal, this is the main diagonal of the given matrix. So all the entries below the main diagonal are 0. So therefore this is upper triangular matrix. And in this matrix, this is the main diagonal of the matrix and all the entries above the main diagonal are 0. Therefore it is lower triangular matrix. So a square matrix in which all the entries below main diagonal are 0 is called upper triangular matrix, and a square matrix in which all the entries above the main diagonal entries are 0 is called lower triangular matrix. So definition depends on the main diagonal of the square matrix. If entries below the main diagonal are 0, square matrix is upper triangular. And if entries above the main diagonal are 0, then square matrix is called lower triangular. And square matrix is triangular, either it is upper triangular or lower triangular. So triangular matrix means a matrix which is either upper triangular or lower triangular or both. And you are familiar with diagonal matrix also. We just revise. Diagonal matrix is square matrix in which all the entries except main diagonal entries are 0. So it is like this. Suppose we consider 3 by 3 square matrix, and if this is the diagonal of 3 by 3 square matrix, then all the entries except this diagonal must be 0. Diagonal entries can be 0 or non-zero. We don't have to worry about diagonal entries. But if all the entries except main diagonal entries are 0, then square matrix is called diagonal matrix. So we can see diagonal matrix is upper as well as lower triangular. It is upper triangular because all the entries below the main diagonal are 0. It is lower triangular because all the entries above the main diagonal are 0. So diagonal matrix is always triangular. This is the example of diagonal matrix. This is the diagonal of this matrix and all the entries except these 3 entries are 0. We can consider 0 matrix also. 0 matrix is always diagonal because if this is the diagonal, then remaining entries are always 0 in 0 matrix. So as we discussed, diagonal matrix is always triangular matrix. Now we are interested in the eigenvalues of a triangular matrix. So eigenvalues of a triangular matrix are the entries on its main diagonal. This is true for any triangular matrix. If we have triangular matrix, then its eigenvalues are nothing but the entries on the main diagonal. For example, this is triangular matrix, therefore here 2, 3, 7 are eigenvalues of this matrix. So if our matrix is triangular, we can directly write down its eigenvalues without solving its characteristic equation. We don't have to go for solving characteristic equation if our matrix is triangular matrix. We can consider some examples. Find the eigenvalues of the following matrices. So this is 2 by 2 matrix, and we can see entries below the main diagonal are 0. There is only one entry below the main diagonal and it is 0. Therefore this is lower upper triangular matrix because entries below the main diagonal are 0. Therefore its eigenvalues are entries on the main diagonal, which are -1 and 5. So we have to write in this way: in given matrix all the entries below main diagonal are 0 and hence it is upper triangular. If all the entries below main diagonal are 0, matrix is upper triangular. If all the entries above main diagonal are 0, matrix is lower triangular. So it is opposite. If below, then we consider upper. If above, then lower. So this is upper triangular matrix, therefore it is triangular matrix, and eigenvalues of a triangular matrix are its entries on the main diagonal. So here lambda equal to -1 and lambda equal to 5 are eigenvalues. This is another matrix. We can concentrate on the main diagonal. So we observe that entries above the main diagonal are 0. These are the entries above the main diagonal, and all entries above the main diagonal are 0. Therefore this matrix is lower triangular. A given matrix is lower triangular because all the entries above the main diagonal are 0. Therefore eigenvalues are entries on the main diagonal, which are 3, 7 and 1. So lambda equal to 3, 7, 1 are eigenvalues of given matrix. This is another example of triangular matrix. These are the diagonal entries, and we can see all the entries above as well as below main diagonal are 0. Therefore this is upper as well as lower triangular. In fact it is diagonal matrix because all the entries are 0 except main diagonal. So this is example of diagonal matrix, and diagonal matrix is always triangular. So in this case eigenvalues are -1 by 3, 1 and 1 by 2. -1 by 3 is repeated eigenvalue. So given matrix is upper as well as lower triangular. Therefore lambda equal to -1 by 3, 1 and 1 by 2 are eigenvalues of given matrix. So if your matrix is triangular, then you can find out its eigenvalues directly. Eigenvalues are nothing but the entries on the main diagonal. So whenever we will have triangular matrix, and if we are interested in the eigenvalues of triangular matrix, we will write down diagonal entries directly as the eigenvalues. So this is all about today's session. In next lecture we will discuss some more results on eigenvalues and eigenvectors. Thank you.